Okay, so as I was saying, this gamma here is 2, so it means that this term is 1, and then the ratio of the variances will remain. So that's b is just equal to the ratio of the variances down here. Um, so in this special case, because eta is equal to 1, then it turns out that the variance of the relative price is actually just the variance of z, which is the demand shock. So you'll recall that we had a demand equation that looked like this: y zi pi divided by p, and then there was a negative eta there. So z here, as you recall, is just a demand shock. Okay, so in this special case, because of eta being equal to 1, the variance of the relative price is just equal to the variance of the demand shock. And then the variance of P is just equal to the variance of the money supply. So I'm not going into why that is, but it just happens to be true for this particular parameterization. Okay, so then if you have output is equal to this expression, now this is from the last slide, so if I just flip back here, you can see that we have this expression. Okay. Well, if you plug in b here, then you're going to end up with this. So for instance, if you just do b divided by 1 plus b is equal to vz divided by vz plus vm, that's b, divided by 1 plus vz divided by vz plus vm. Okay, so there's going to be vz plus vm here. We're going to be able to cross out these guys, and we're going to be able to write is equal to vz divided by 2vz plus vm, which is what we have here. Okay, so that's what we get. Output is just the surprise in the money supply times this term here. Okay, so here I've got an implication. The higher is Vm, the smaller is the effect of a money surprise. So I'm going to actually have that with more, oops, yeah. So let's talk about that again. So the idea is if Vm is large, so remember the term that's multiplying here is Vz divided by 2Vz plus Vm. Okay, if Vm is large, which is equivalent to B going to 0, then basically these money shocks are super big. Money is jumping around all the time, but the demand shocks are relatively small, so they don't matter that much. So if money is jumping around all the time, then if they see their own price change, they just say, well, there goes the government printing money again or destroying money again. So they don't actually respond to the change in prices. On the other hand, when Vm is low relative to Vz, then it means that there's very little change in the money supply each year. So if I see my price being different than I expect it to be, I'm going to assume that that was a demand shock. Okay, so I'm going to really it's really going to affect my my production. Okay, so the relationship between the variance of money supply and the effect of money supply on output is should be negative. Okay, so we can actually test that in data. That's what we have on the next slide. So we're going to regress real on nominal GDP per country. So what we want that to reflect is how does output correlate, at least, with money supply, with shocks to the money supply. All right. So if tau is positive, what that means is that there is a correlation between money supply and output. So in other words, money supply does seem to drive output. All right. On the other hand, or not on the other hand, but on the other axis, what we're going to put here is just the volatility of nominal GDP. So like you can think of it as the volatility of prices, or more generally, the volatility of the money supply. Okay, so what we expect is in countries where the money supply is really jumping around a lot, there's not going to be much of a relationship between the amount of money or the price level in the country and output. In countries where the money supply doesn't change very much, if the money supply changes, we're going to expect it to cause, at least in this model, a higher output. Okay, so let's see if that's true. And sure enough, you won't be surprised that we see there's a negative relationship here. That might be a bit of an exaggeration, but certainly it would be something like this if you were to run a regression properly. So what this says is there's a negative relationship which says that the more volatile your money supply is, or your price level is, your average price level, the less output responds to changes in the price level. In fact, maybe kind of surprisingly, in some places actually, there's a negative relationship between output and nominal price. So it says that when nominal GDP is high, real GDP is low. But whatever. So anyway, this is some limited evidence that there's something to this model. At least one of the predictions of the model seems to be borne out in the data. Okay, so I think this might be my last slide. It is. Okay, so just kind of finishing up on this Lucas model. So again, let's think about what the point was. So the point is to try to get money to have an effect on real GDP, on real output. And in this model, we did that by having firms that would see changes in their own price and then not be sure whether that was due to a demand shock, in which case they want to produce more, or due to just an overall change in the money supply, which means that they shouldn't actually produce more. So depending on sort of how volatile these two different things are, demand shocks versus money shocks, they're going to sort of attribute any change they observe in their price partly to one or the other, and you can actually get an effect of printing money on output. Again, why was this model important? It's important because we're micro-founding it. We're saying it's due to information problems at a very low level. We're not assuming any sort of statistical relationship. We're assuming that firms are sort of optimizing the best they can given their information. It's their information that's limited, et cetera, et cetera. So what are some, so let's talk about first the contributions, then we'll talk about the objections. So the contributions, it's fully micro-founded, and it shows a way that you can get money to have a real impact on the economy. Rational expectations, whether that's good or bad, that's certainly something that has been true of many macro models over the last 30 years, 40 years. And then finally, it shows how one way at least you can generate this relationship between money supply and the real economy. Even when people are making perfectly rational decisions, they realize that printing more money doesn't make you more productive or anything like that. So that's one thing. What are the objections? Well, it turns out that announced disinflations have real effects. So if the central bank says, hey, tomorrow we're going to print money, when they actually print money, that can have a real effect anyway. I don't actually think that's so much of an objection. I think that usually when the Federal Reserve makes an announcement, it's the surprise in the announcement that has an effect. And when they actually do change the interest rate, then it's sort of the surprise in that change that has the effect. So I'm not sure how strong that objection is. The real objection in the model is the second one here, which is the information structure is a little bit weird. Why is it that firms can't observe the price of their competitors? We know that there's a huge industry that is basically, sometimes you go to grocery stores and you see people writing down prices. Often those are for companies that will sell that information to all of the grocery stores, because every grocery store wants to know what its competitors are charging on each of the products. Moreover, aggregate price indices are collected by the government and they're produced quite quickly. So, certainly at the time frame of like a month or a quarter, it would be weird to assume that producers wouldn't be able to see what the general or the average price level is. A really high elasticity of labor supply is required, so you need to have gamma to be 2 or less, right? So otherwise there's not much reaction. You recall that if gamma is too high, that means that people really dislike working more. So if you change the prices, the households don't really respond. And it turns out that in the real world, people pretty much work full time. I think I've said this before. So there actually isn't much response uh, of labor to prices or wages. And then finally, this is a one-shot static model, so it has no method of having propagation or persistence. In the real world, when there's a shock, a recession doesn't just last for one moment and then go away. It often kind of takes a long time, and then the economy recovers over a long time. And this model won't actually tell you why that's happening. So that's it. But I mean, this was a very influential model, and I think it's still an interesting mechanism that has something to it. So yeah, so that's what we had. That's what I have to say about that.